Viewers, today we're going to discuss about Pascal triangle. A Pascal triangle is one of the alternatives we have, a good alternative to expanding brackets. For example, we have to expand 3p plus q raised to the power of 3. Our elementary knowledge about this is to write this bracket in 3 places, expand the first 2, and use it to expand the 3, then we collect our like terms and group other things. While that is also correct, this is a perfect method that will help us when the power of the bracket is much. For example, if you have 3p plus q raised to the power of, let's say, 5 or 10. But imagine writing the brackets in 10 places. Let's say we find the 2 by the 3rd by the 4th. It will take time. So a better method is used, called a Pascal triangle. We can have other methods too. We can use our combination methods. But let's use the Pascal triangle. The Pascal triangle is just a succession of numbers. It is something like this. 1, we have 1 and 1. We have 1. 1 plus 1 is 2. We have another 1. 1 plus 1 is 3. 2 plus 1 is 3. 1. 1. 1 plus 3 is 4. 3 plus 3, 6. 3 plus 1, 4. 1. 1. 4 plus 1 is 5. This is 10. This is 10. This is 5. This is 1. Continuously. But you don't need all of them. It is a succession as I've told you. So to solve this, what do you need? Look at the one that have 3 and 3 in between. Or count 3 coaches downward. 1, 2, 3. This is what we are going to use. How do we use them? It's simple. Let's use them to expand this bracket. That is our 3p plus q raised to the power of 3 will be equal to, just watch well. You write the first leading number here, 1. 1 times. The first term here is 3p. As the power of the first term is decreasing, the second term will increase. The first term is 3p raised to the power of this 3. Then times second term q raised to the power of 0. After I go for 3. Plus 3 times our first term will decrease by 1. The second term will increase by 1. Plus, go for the next 3. This one here. 3. Our 3p, which is the first term, will decrease by 1. Our q will increase by 1. And go to the last term, the last coefficient, which is 1. This one here. Times our first term, 3p, will also decrease by 1 to become 0. Our q will increase by 1 to become 3. Just look at it and very well, you will discover with me that from the beginning, 3p has a power of 3, q have 0. The last term, 3p now have 0, q have 3. So as the first term is increasing, the second term or the next term will decrease. Okay, so this will be equal to, still write your 1 times 3 here is standing for both these 3 and p. So 3 here, power 3, just like saying 3 times 3 times 3, that is 27. So we have 27 p power 3. Q raised to the power of 0 is 1. For a lot of indices, any number raised to the power of 0 is 1. Plus 3. 3 square is 9. P square. Q power 1 is still Q. Plus 3 into 3 power 1 is still 3. P power 1 is P. Q power 2 is Q square. Plus you write your 1. 3p power 0 is 1. Q power 3 is Q cube. Alright, so the next step now is we simplify by multiplying. 1 times 27 is 27, times 1 is still 27, with P cube is 27 P cube. 3 times 9 is 27, arrange your P square and your Q. 3 times 3 is 9, 9P Q power 2, and then lastly 1 times 1 is 1, times Q power 3 is Q power 3. Observe it very well. If you look at what we have done here, here P is 3, Q is 0. Here P became 2, Q is 1. P became 1, Q is 2. P became 0, Q is 3. So that is how to solve or to expand fractions, to expand brackets using partial fraction. Contact me on my WhatsApp line for any personal issue. But don't forget to like, share, and comment.